Hi, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This is a video for my grade 10 students, and in this video we're going to find the standard form equation of a perpendicular bisector. So, let's just talk about what a perpendicular bisector is. As a reminder, a perpendicular bisector requires us to start with a line segment. So this is a quick line segment. I just drew it randomly in space. I didn't even use a ruler. Sorry about that. But that's line segment AB. And somewhere exactly halfway between A and B is the midpoint, so that it's exactly equidistant between both A and B. So if you want to use a really fancy word for midpoint, it can be a point that bisects a line segment. So bisects means cuts in half perfectly. So not just cuts in half, like randomly, like you might cut a cake in half and then take the bigger piece, I don't know, but truly in half. So a midpoint is a point that bisects a line segment, meaning it's, if you were to cut it at the midpoint, you've got exactly equal pieces. So when we say a perpendicular bisector, we're talking about something related to the midpoint. So it's a line that definitely has to pass through the midpoint so that it will cut that line segment AB in half. So the word perpendicular, what that tells us is that it's a line that passes through that midpoint that is also perpendicular to the line segment. So not only does it have to go through the midpoint, but it also has to be perpendicular. That's what a perpendicular bisector is. So let's look at a question in which we find the equation algebraically. Here's the question we're going to work on. Determine the standard form equation of the perpendicular bisector to the line segment that passes through these points. So point A and point B. So again, we need to know when we read this what a perpendicular bisector is. And even at its most foundational level, this is a line, right? A perpendicular bisector is a line. And we know that lines take the form y equals mx plus b. And also lines take standard form ax plus by plus c. But as we've talked about, we don't start by looking for the standard form equation of a line. We start by looking for the slope-intercept equation of a line. So for now, let's ignore this standard form thing and just focus on determine the equation of the perpendicular bisector. So we know that that's saying determine the equation of the line, that is this thing called a perpendicular bisector. And it's a perpendicular bisector to this line segment. So again, if you think about the diagram we just drew, line segment AB exists in space somewhere, and there's a midpoint. So that's where I would start. I know that the perpendicular bisector, I'm just going to call it PB. I sometimes actually say peanut butter line. Weird. The perpendicular bisector goes through the midpoint of line segment AB. So I'm going to find the midpoint of line segment AB. That makes sense because I know my perpendicular bisector goes through the midpoint. So let's do that. Let's find the midpoint of that line segment. So the midpoint of AB is, so the formula we know is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So I have negative 4 plus 10 is 6 divided by 2, and 5 plus 9 is 14, yes, divided by 2. And so if we simplify all those fractions, we end up with a midpoint, which is 3, 7. So this midpoint is the midpoint of AB, here, over on the side visualizing. So I know where the midpoint of AB is. It's right here at the point 37. And the line I'm looking for passes through that point. So this is a point on my line. Oh boy. Sorry, my pen is being really messy right now, but you can hear me. So you should know what I wrote. I wrote the word point, not the word pant or paint. This is a point on the line. That's great. I need two things to write the equation of a line. I need a point on the line. Got it. And I need the slope of the line. Okay, so slope. How do we find the slope of this line? Well, again, it's a perpendicular bisector, which means that it's perpendicular to the line segment. So if I can find the slope of the line segment, then I can use that information to find the slope of my line. So let me clear up some room here. So what I now need to do is I need to find the slope of this line segment through AB. So I've just made a quick copy of that information. Those are the 2 points. So we had just found the midpoint, and now we're going to find the slope of that line segment. So slope. So slope of AB is, so slope is y2 minus y1 over x2 minus x1. And of course that definitely needs a bracket because we're minusing a negative. So in the numerator, on top I have 9 minus 5, which is 4. And in the denominator I have 10 minus negative 4. Well, that's 10 plus 4. So in the denominator I have 14. So I have a fraction, and we always want to reduce fractions. Both the top and the bottom can be divided by 2. So this reduces to 2 over 7, because divide by 2, divide by 2. So the slope of AB is 2 over 7. My line is perpendicular to this. So I need the perpendicular slope. So we remember how to find the perpendicular slope. This is the slope I was given. I'm going to flip the fraction upside down. So instead of 2 over 7, 7 over 2. And I need to change the polarity. This is a positive slope, so my perpendicular slope must be negative. So the perpendicular slope is negative 7 over 2. That is the slope of my line. So I now have the slope of my line that I'm looking for and a point on the line. That's the information I need to write the equation of a line. So let's start doing that. So I'll go this way. So what do we know? We know that there is a slope of negative 7 over 2, and there is a point of 3 comma 7. I'm just going to double check because I don't want to have that wrong. Yay, I got the slope right. And yay, I got the point right. Okay, so that's the information we have. We found the midpoint, that's the point. We found the slope and made it perpendicular. That's our slope. So to find the equation of a line, we always start with y equals mx plus b, where m is the slope. So I'm going to write the slope. Y equals negative 7 over 2x plus b. I don't know why I put a bracket there. I think I was thinking ahead to the next step. So the point I was given is not the value of b because it's not a y-intercept. But again, the point I was given is an x value and a y value that I can use right here in the equation. So I'm going to let y be 7. And now I'm going to substitute for x3, 3. And now I'm going to solve for b. So we always start by looking at what's happening in this multiplication. So what I have is negative 7 over 2 times 3 over 1. And I like to see that if I'm doing multiplying fractions, because then I can just do top times the top, bottom times the bottom. So 7 equals negative 21 over 2 plus b. Okay, so I multiplied negative 7 over 2 times 3, and I got this number. And it's a fraction, and it doesn't reduce any further, so I'm going to leave it like that. But to help me solve for b, I'm now going to multiply by 2. And I'm allowed to do that as long as I multiply everything by 2. So 7 times 2 is 14. Negative 21, well, if I multiply by 2, I'm just canceling the divide by 2. So that's just negative 21. And positive b times 2 is positive 2b. That just means you don't have to. It just means that I don't have to deal with common denominator fractions. For me, this is faster. So now I want to solve for b. So first I'm going to add 21. So 14 plus 21 equals 2b. So 14 plus 21 is 35. So 35 equals 2b. I want b, not 2b. So I'm going to now divide by 2, divide by 2. And that gives me 35 over 2 equals b. That doesn't reduce, so I leave it as 35 over 2. And now I can write the equation of my line. So if we go back up here, we knew the slope was negative 7 over 2. And now we also know what b is. So we can write the equation of the line in slope-intercept form. So let's do that. So y equals negative 7 over 2x plus 35 over 2. That is the equation in slope-intercept form. And now I remember that we wanted it in standard form. So let's do that. Standard form is the form that looks like this. Everything's on the left. There's no fractions, no leading coefficient that's negative. But let's start by putting everything on the left in proper order. So first, the x term should be on the left. So the x term right here is a negative term. So when I remove it from the right, it becomes positive 7 over 2x. So that goes first. Then the y term. So the y was already on the left side of the equal sign. So I don't change anything about it, but I do write the positive sign in front of it because this was positive y. We just didn't have to write it until now. Now I have this other number, the constant. There's no x or y. So I need that to also move to the left. Right now it says positive 35 over 2. So it would now be subtract or minus 35 over 2. And then I've moved everything to the left, so I'm left with equals 0. So step 1, everything's on the left side. Now there are fractions. So I'm not allowed to leave fractions in standard form. So to get rid of them, both of my fractions exist because of this divide by 2 that's happening. So to get rid of divide by 2, I'm going to multiply everything by 2. So when I multiply this by 2, what's going to happen is the multiply by 2 just cancels that divide by 2, and I'm left with 7x. When I multiply this by 2, it'll become 2y. When I multiply this by 2, this multiply by 2 just cancels that divide by 2, so I have minus 35. And of course, 0 times 2 is still 0. And the final thing to check is the leading coefficient positive? Yes, it is. So I don't have any more to do. This is proper standard form, and it is the perpendicular bisector of the line segment AB that we started with. And I can't remember what A and B are at this time, but you could pull the video back. I hope that was helpful, and have fun studying your math. Bye.